is example 15.4. We have 1 minus tangent beta cubed equals cotangent beta minus 1 over cotangent beta secant squared beta minus 2 tangent beta. Now, how are we supposed to solve this? Let's start with which is easier to deal with. I think it's easier to... The left-hand side looks friendlier, so let's start with the more complicated side. And let's hope that we will be able to transform it into the simpler form on the right. But if we get stuck somewhere, we can just stop there, then treat this as a left-hand side, then hope that we can transform this into whatever we get here as a result. Anyway, let's just see what happens. So, what can we do here? Okay, cotangent, if I split this fraction over the subtraction, I will get 1 minus tangent beta. Is that clear? Okay, now, what do you notice here? You have several trig functions here, but all you have here is a tangent function. So perhaps we can express everything here in terms of tangents. We have an identity concerning tangents. We know that secant squared beta is equal to 1 plus tangent squared beta. And copying the rest, this one. And here, what do we get here? We have a quadratic form in terms of tangent beta. It's not clear. Let me rewrite it as tangent squared beta minus 2 tangent beta plus 1. Or maybe I should have just rewritten it as 1 minus 2 tangent beta plus tangent beta squared. What's wrong with my pen? Okay. Something's wrong. Anyway. So, we can factor this into 1 minus tangent beta, 1 minus tangent beta squared. Okay, then we get the result that we want, 1 minus tangent beta cubed. Okay, so this is example 15, number 5. To solve this problem, we start with the right-hand side. So we start with this. This is a square of a binomial, so all we have to do is expand it. After this, look at our target expression. It involves cosines, and it just involves cosines. So let's rewrite this in terms of sines and cosines. This is a 1 over sine squared alpha minus 2 cotangent alpha is 2 cosine alpha over sine alpha. And since we have a cosecant alpha, we're supposed to square this. Plus cosine squared alpha over sine squared alpha. Then we end up with 3 fractions that have the same denominator, so it should be easy for us to combine them. And for the denominator, take note that since we want an answer in terms of cosines, we know that sine squared is equal to 1 minus cosine squared alpha. Then all that's left for us to do is we just need to factor these. Okay, and from here we cancel, and we get the needed result. Okay, this is example 15.6. So, to prove this, we're starting with the left-hand side because it's easier to collapse an expression than to expand it. Okay? So from here, we just combine this fraction. Using the LCD, we get cosine squared x plus 1 plus sine squared x over 1 plus sine x cosine x. Okay. Next, expanding this. I'm sorry. This is wrong, huh? This is the expression that's squared. Okay. So expanding this binomial, we will get cosine squared x plus 1 plus 2 sine x plus sine squared x. Okay. Then what happens next? Let's copy the denominator. We see a cosine squared and a sine squared. We know that that is equal to 1. So we have a 1, this is a 1 plus 1, 2 plus 2 sine x over 1 plus sine x cosine x. And from here, the remaining steps should be clear. So you can factor out the 2, so you will get a 1 plus sine x, which cancels with the 1 plus sine x in the denominator, cosine x. And we know that cosine x is secant x. 1 over cosine x is secant x, which is our goal.